Hey everybody, this is 5.1, switching to intercept form. So in our last unit we talked about graphing in intercept form, but this unit we're going to be talking about standard form. And it's really difficult to graph from standard form. This is standard form, okay? And to solve in standard form is kind of difficult. So today we're going to be talking about switching that from this form into intercept form. All right, so we've talked about standard form before. A does the same thing that it has before. That tells us if it's like opening up or down. Okay, it's like we can use it for like the direction of opening and behavior. And C is kind of nice because it will give us the Y-intercept. In the past, if we wanted to find the Y-intercept, we plugged X in for 0. And if you did that here, A times 0 squared, that would cancel, and B times 0, that would cancel, and we'd just end up getting, I guess I should get rid of that first. We would end up getting 0, C. So whatever C is, that is the Y value for our Y-intercept. So that's kind of nice. But we want to switch it into intercept form so that we can graph easier and solve easier. Okay, so if you kind of look at the two forms, how do we go from here to here? Well, this is what we call factoring. C unit 3. Okay, so we spent a whole unit learning how to take something in standard form and writing it in intercept form. Okay, we just didn't know that's what we were talking about. Okay, so here's just a few examples. If we want to factor, again, we always want to, so number 1 maybe, put a star on that. We want to make sure that, see if there's a greatest common factor. And another thing we also want to make sure, maybe even before that, I'll put a star in front of that, would be to make sure it is in standard form. Because if it's not in standard form, then we can't factor trinomials. Okay, so this one's all ready to go. So we need to find something that multiplies up to 25x squared and then adds to give us negative 12x. So again, if you're ever stuck, write down some factor pairs like 1 and 35. 2 doesn't go in, 3 doesn't, 4 doesn't, 5 and 7. And I think that's about it. So the only thing that would make that work would maybe be 5 and 7. And they would both need to be negative. Okay. We also talked about using a shortcut if A is 1. And if that's the case, then we can write our answer really quick. So it was x minus 5 and x minus 7. Again, this only applies if A is 1 or there's not a number in front of the x squared term. Okay. If you prefer not to use the shortcut, then we can still do grouping. So we'd do like x squared. We'd replace that negative 12x as negative 5x minus 7x. And that's still the same. Those are the same. And we would do grouping. So we would cut that in half. Greatest common factor for the left side would be x, and what would be left would be x minus 5. And then here, greatest common factor, looks like we could divide both sides by negative, or both terms by negative 7. So we can factor out negative 7, and we'd get x minus 5. Again, those have to be the same, so that would be x minus 5. We could factor that out, because there's an x minus 5 in both of those terms. And then what's left would be x minus 7. Again, that is the same. Okay. We can use that shortcut if A is 1. All right, so here are B and C. Why don't you pause and give those a try and see if you can remember how to factor. Okay, so here it looks like we could factor out a 2. Before we do anything, we should always check for that and take out the greatest common factor. What multiplies to negative 20 and adds to 1? Well, that maybe be something like, no, not that, maybe 5 x minus 4x. Again, we can always write down factor pairs for 20 and see what we could come up with. 1 and 20, 2 and 10, 4 and 5, and that's your choices. Here we can use the shortcut because we factored out that 2. So we'd have x plus 5 and x minus 4. Again, you're welcome to do grouping if you'd like. All right, and then the last example, so this one actually is an equation, but we would do the same sort of thing. We would do glasses, see what multiplies and adds to negative 8x squared and adds to 7x. And it looks like we could maybe do 8x minus 1x. So here, we cannot do this. We can't get our answer as x plus 8 and x minus 1. That's no-no because a is not 1. We can't use the shortcut. So we would have to do grouping. So 2x squared plus 8x minus 1x minus 4. And then we could do grouping. Cut it in half. Factor out a 2x. What's left would be an x plus 4. And here we could take out a negative 1, and we'd have x plus 4. So again, those are the same. And we have 2x minus 1. So this one, it's actually an equation. So when we're done, we should have y equals those two parentheses. Okay? All right, so there's a quick review of factoring. So this is what we're going to do, really, what our goal is for today is being able to switch forms, graph, and find key features. So what we just covered or reviewed was factoring. That was, again, Unit 3. And then once you have this into intercept form, then it's what we covered in Unit 4. So it's kind of like just bringing it together. So here, there's no greatest common factor. It's already in standard form. So we need to find what multiplies to 15x squared and adds to the middle term, which is negative 8x. Looks like maybe 3 and 5, both of them negative, so negative 3x minus 5x. We can use the shortcut, and we'd get x minus 3 and x minus 5. Okay, so some of your homeworks, I don't give you the graph paper. So you could do a sketch if you'd like. Let's see what we can do without using our graph paper at all. So over here I'm going to write our equation again. So y equals x minus 3 and x minus 5. So if we want to find the x-intercepts, again, x is lie. Or you can also think of like what makes that be 0. Okay, what makes x be to make that 0. So our x-intercepts would be 3, 0, and we have 5, 0. All right, so that would be our x-intercepts. And then our y-intercepts, again, we kind of mentioned this at the very beginning, that the constant gives us our y-intercept. So here, it's 15. You have to look at your equation in standard form, because in standard form, intercept form, we can't find our y-intercept. So we look over at our original equation. Here's our c, it's 15. So our y-intercept would be 0, 15. Axis of symmetry, again, it's halfway between 3 and 5, which would be 4. So x equals 4. Vertex, so this one might be a little tricky unless you did it algebraically. So the vertex is 4, something. And that something we can find using our equation. We can evaluate our equation when x equals 4. And it doesn't matter which one you do. So you could do y equals 4 minus 3 and 4 minus 5. And you'd get 1 times negative 1, which gives us negative 1. So our vertex will be 4, negative 1. Again, that's like your y for your vertex, and the axis of symmetry is like the x for your vertex. Okay, so we found that without graphing, and then increasing, decreasing. So here I would probably recommend that you do a little sketch of what's going on, and maybe we'll just graph it on the graph paper. So here we have a point at 3 and 5 for our x-intercepts, and then we found our vertex was 4, -1. We could continue our growth pattern using 1, 3, 5. And then let's answer our question here. So where is it increasing? So again, it is the right side of our axis of symmetry. So it goes from 4 to infinity. So if you realize that, and you realize that it's opening up, you could easily come up and use our axis of symmetry and use an infinity, and you'd be okay. But sometimes it's just kind of hard to just look at it in your mind. So again, I think it's good to like write down or do a little, at least a sketch of what's going on, and I think that will help. Okay? And then decreasing is just the other side, from negative affinity to 4. All right, so here's another example. Pause and give this a try if you'd like. Notice that this needs to be fixed. It was a -8 at the end, but it's a it should be a +8. So here we could factor out a 2. Now a is 1, so we could use the shortcut. Needs to multiply to 4x squared and adds to 4x. So it would have to be 2x plus 2x. So our equation here would be 2 times x plus 2 and x plus 2. Okay, so if we wanted to write down our x-intercept, well, here you'd probably realize that it's -2, 0 and -2, 0. Okay, since that's the same point, you don't need to write it twice. If you do, it's fine. I won't take points off. Okay, but that also means that, like, what would be our axis of symmetry? Well, our axis of symmetry is halfway between -2 and -2. Well, that's just -2. So our axis of symmetry is here. Okay. And since there's like no growth pattern to kind of go backwards, like typically sometimes we went backwards, or if we wanted to use do it algebraically, again the axis of symmetry is x equals -2, and you plug that into your equation, you'd end up getting y equals 0. So our vertex is the same as our x-intercepts. And then we could use our growth pattern over 1 up 2, over 1 up 6. Something like that, okay? And we could answer these questions. So we've got x-intercept of -2, 0, y-intercept. Here you could look at your graph, but if not, you could look at your equation and see that it's 8. So 0, 8. Axis of symmetry is x equals -2. Vertex was -2, 0. Positive and negative. So this one's a little tricky. Where do we have positive values? Well, you might be tempted to say from -infinity to infinity, but there's one point that's not positive. It's the vertex. The height here is 0, so it's not positive or negative. So it would be positive from -infinity to -2, and it would stop, and then it would start again right after -2. Okay, and here we would have no negative values. All right, so here's another example. If you wanted to pause and do the problem, or if you just want to kind of look at it, the only thing I wanted to notice is that we have a leading negative, and that needs to be taken out before you do anything else. Okay. Last thing we need to talk about is solving. So it's basically the same as what we did above. We'll need to put it into intercept form, and then from there we can find our solutions. So I already did B and D. If you, at the end, if you want to pause and like look at that or try those, okay? But here, there's no greatest common factor. It's in standard form. So, oops, I missed that negative. I want to include that. So multiplies to -10 and adds to give us 3. So maybe 5 minus 2. And we can use our shortcut. So x plus 5 and x minus 2. You're probably going to have more problems where you'll be able to use the shortcut, just because it does take a little longer to do grouping. Anyways, we want to find our solutions. Again, it's similar to the X-Intercepts, but we write it differently. So again, if it helps you, you can do like x plus 5 equals 0 and x minus 2 equals 0. Okay, so here we would subtract 5 to both sides and would get x equals negative 5. And here we could add 2 and we would end up getting 2. So our two solutions would be negative 5 and 2. Okay, here's one more that we'll probably go through. Again, there's no greatest common factor, and a is not 1, so we would need to use grouping. So we need to multiply to 70 and adds to 3x. Again, write down some factor pairs, and eventually you'll get it. So 3 doesn't go, 4 doesn't go, 5 does, 5 and 14, and then we could do 7 and 10. So 7 and 10 would work. We'd maybe do 10x minus 7x. Can't use a shortcut, so we'd have to do plus 10x minus 7x minus 35, and we'd do grouping. So here it looks like we could take out a 2x, and this side we could take out a negative 7. Okay, and then those are the same, so we could factor that out. Okay, and you can do the same thing we did before. Either x plus 5 has got to be equal to 0, or 2x minus 7 has got to be equal to 0. So we could subtract 5 to both sides, so we get x equals negative 5, or we could add 7 and divide by 2, so 7 halves. All right. C, I'm not going to go over this, but one thing we need to notice is that this is not in standard form. We would need to subtract 3 to both sides, and then we'd do glasses, okay? So that's the two things we need to maybe remember, is it needs to be in standard form, meaning highest exponents to the smallest, and then this is kind of new, we have to have it equal to 0. And then always make sure there's a greatest common factor. All right, well, if you have any questions, let me know. I will see you later.